Hello, this is question 4 from the 2007 Matt. Looks like we've got some geometry going on, which is good. In the diagram below is sketch the circle with center 1, 1, radius 1. Okay, that's not actually on the picture, so I'll put that on for now. There's the center. I mean, you can see from the picture that what the radius is going to be once we've got the center there. Line L. Okay, what's the line? Oh, line L is tangential to the circle at Q. So that's this line that's running between R and P with Q somewhere in the middle. Further, L meets the y-axis at R, yep, the x-axis at P in such a way that OPQ, yep, is angle theta. Okay, right, so it was only the centre that I hadn't put on. I like putting on touch points for circles, so I'm going to mark on the 3 radii, which are going to the tangential lines, the x-axis, the y-axis, and the line L at Q. These lines are nearly always useful. So, right, let's get on with the first part of the question then. Show that the coordinates of Q are 1 plus sine theta, 1 plus cos theta. The gradient of PQR is minus tan theta. Okay, right, quite often with these, it's not immediately apparent what to do, but there are a number of things that are pushing us in a certain direction. Number one being that there's only one fixed point, really, that we've got on here, and that's the centre of the circle. I mean, I suppose we do know the touch points here on the x-axis and the y-axis, but they're further away from Q. So it feels as though we need to work from the coordinates that we know, the ones we've been given at the centre of the circle, especially as they're pretty close to Q. Plus this gradient is minus tan theta, certainly putting in mind having a negative reciprocal of the gradient of the radius from the centre of the circle up to Q. So everything's pointing us towards working on a triangle somewhere off of C, the centre of the circle, up to Q. So I'm going to start drawing that out. So that's C to Q. We've got the radius between them of length 1. We need to get theta into this somewhere. This is another reason to start off of there. Of course, look at these coordinates. We've got a 1 and a 1 already in there for x and y. We're just adding on a sine theta and a cos theta. So it makes me think that if we can get a theta into the right place in a right angled triangle with that one radius, that length of 1 radius as the hypotenuse, then everything's going to be fine. So how are we going to get theta in? We've got the tangent at Q. We're going to need some horizontal lines. So let's put in a horizontal line there, because at least that gets us theta into the picture. Because that is, yeah, that's fine. You know, we've got theta down here, haven't we, at P. So that's got theta in the picture, and we've got these right angles. So that's going to mean that that is theta. And now everything, let's just move that 1 down, make it clear that it's next to the hypotenuse. So this length here is sine theta, and this one is cos theta. And C is at 1, 1. So this diagram now says it all. So we can say then the coordinates of Q are, well, exactly what they want. It's going to be 1 plus sine theta for x, and then 1 plus cos theta for y. Now we need the gradient. So the gradient of CQ, so we want the change in y over the change in x. So that is going to be cos theta over sine theta. So therefore the gradient of L equals minus 1 over the gradient of CQ. So gradient of CQ, and that is going to be minus tan theta. So happy days. Right, that is, oh, we've still got another part of this question. Write down the equation of the line PQR and so find the coordinates of P. So the line PQR, okay, well, we've got the gradient and we've got a point on the line, right? So we can just do our y minus y1 is m times x minus x1. So we just need to stick all of that in. So we've got, put that in quotes just so they know what you're doing, equals m x minus x1, and then off we go. So we've got y minus 1 minus cos theta equals minus tan theta x minus 1 minus sine theta. So yeah, that's the equation of the line. I didn't say to have it in any particular format. Find the coordinates of P. Let's do that then. The coordinates of P, so at P, y is equal to 0. So we just need to plug all of this in. We can get rid of these minus signs as well. That'd be another thing that's useful. So yeah, so y is 0. Get rid of the minus signs. So we're going to have 1 plus cos theta. 1 plus cos theta. Divide by the tan theta, which doesn't have the minus sign anymore because we cancelled that on both sides. Then we add on 1. Then we add on sine theta. And that is giving us x. Because yeah, we know what y is for x. So we must be able to simplify this in some way. So x is going to be equal to what we're going to have. We've got cot theta there for 1 over tan. So we've got a cot theta. We've got a cos theta divided by a tan theta. So that's going to be cos squared divided by sine. So 1 minus sine squared divided by sine theta. And then we've still got the 1 and we've got the sine theta. So, okay. Sine squared divided by sine gives us the sine. Oh, and that's going to cancel. Right, okay. So we've got a lot of things cancelling here. So we've got a cot. Well, not a lot of things. 2 things. Cot theta. Nothing's going anywhere with that. We've got then a cosec theta. We've got the sine minus sine squared over sine plus sine is all cancelling out, and then we've got the 1 left. So that is our x coordinate. So, but they have specifically said to give the coordinates of P. I've dropped off the bottom of the page there, but we're going to have to actually put it in coordinates and say, well, it's cot theta plus cosec theta plus 1, and then y coordinate is 0. So make sure you actually get it in the format that they've asked for. So we've got that. Just as well I did a duplicate of this slide because I've run out of space already. So I'm trying to remember what that is because I want to write that x coordinate. I'm sure we're going to use this on the next slide. So cot cosec plus 1. So we've got cot theta on the wrong slide. Cot theta plus cosec theta plus 1. They wouldn't be asking us to work that out, I don't think, unless we're going to use it. Right, second part of the question. The region bounded by the circle, the x-axis, and PQ. The circle, the x-axis, and PQ, okay, right, has area A theta. That's this one. The region bounded by the circle, the y-axis, and QR, area B theta. Okay, explain why A theta equals B pi by 2 minus theta for any theta. Okay, right, so we've got to explain that. So what are we getting here? So this function A of theta is giving us the area on the near side of the circle. So A of theta gives area on near side of circle. Gives area on near side of circle. Okay. And then B of theta gives the area on far side. So it gives area on far side of circle. Okay. So we need to get pi by 2. Right, so let's go up to the angle at the top then. So we can say angle ORP equals pi divided by 2 minus theta. Okay. So therefore, we can say that B of pi divided by 2 minus theta, which is what they want, is equal to, it's going to be the area on the other side of the circle, equals A theta. Right. For anything, right, calculate A, oh, good grief, right, okay, for pi by 4. Right, so this is going to have to be, yeah, we're going to have to actually mark out the areas on this. Right, let's put my touch points back in again on this. So let's put all those in. So it's saying that this angle here is now pi divided by 4, and we need to work out that area there. Right, so we need to say then, so a of theta, for, well, actually, let's do I want to write a of theta or a of pi divided by 4? Actually, I don't think it's going to matter, is it? So let's do this in general. So a of theta is going to be equal to the area of the kite. What are the points? We haven't got a letter for this one down here. QR. We haven't got an S, have we? So I'll call that C. Let's call that S. Area of kite. C Q P S minus area of the sector of the circle. Area of sector. So that's our word equation for what we're trying to work out, and that's going to give us a theta. Okay, that is good. So what is the, oh, we're going to need the coordinates of P then, aren't we? We need to know where P is. So when theta equals pi divided by 4, P is at, where is P? P x coordinate equals, so we've got cot of pi by 4, so that's 1 over 1 is 1, plus cosec theta, so that's going to be 1 over root 2, so root 2, and then we've got to add on 1, so we've got 2 plus root 2. Okay, so that is that. Then we've got so the, how are we going to work out the area of the sector? So area of sector, I think, is going to be a bit easier than, actually the kite looks possibly easier actually, because it is just 2 lots of that right angled triangle. Area of the sector, so that is, yeah, what is that going to end up being? So in this case, oh, everything's symmetrical. If that's pi by 4, then that is also pi by 4 up there. So it's going to be half of 3/4 of the circle, because we're losing a quarter here in this square. That's a quarter of the circle gone. And because everything is symmetrical, these 2 sectors are going to be the same. So we need a half times 3/4 times pi r squared, and r is 1. So that is just going to end up to be 3/8 of pi. So that is the area of the sector. The area of the kite is going to be equal to 2 lots of this triangle. So 2 lots of half base times height. So 2 lots of half of the base. Now the base is 2 plus root 2 minus 1. That's the length, that's the distance from S to P, because P is at 2 plus root 2, that's the x coordinate, and S is at 1. We take that 1 off. So that is that, and the height is just 1. So the 2.5 cancel, and we end up getting 1 plus root 2. So that means that a theta, or a pi by 4, I should say, it's specifically a pi by 4, isn't it, not theta, is going to be the area of the kite, which is 1 plus root 2, minus the area of the sector, which is 3/8 of pi. Right, okay, that wasn't as bad as I thought it could be. That has completed that. Right, wonderful. Show that area. Right, we're now doing it again for pi divided by 3. Right, so they've made the angle bigger, so things are going to change a bit on this then, because we have to get a different way of working out what the sector is, because we can't say that it's symmetrical anymore. So I can't do that half of 3/4 of the part of the circle. Right, okay. Right, so a pi divided by 3. Let's go then. We need to work out what P is, what the x coordinate of P is. When theta equals pi divided by 3, P x coordinate is going to be equal to, so we've got cot theta, so that is going to be 1 over root 3. 1 over root 3. and then we got cosec theta, so that's root 3 over 2, 1 over, so plus 2 over root 3. Okay, that certainly helps. And then add 1. So we've got 3 over root 3 is root 3 plus 1. Root 3 plus 1. That's our p coordinate. So the area of the kite then is going to be easier. Well, we can do exactly the same as we did before for the area of the kite. We can just say that it is going to be a half times 2 times the 1 hasn't changed, but we do root 3 plus 1 minus 1. So it's just going to be multiplied by root 3. So we're going to have root 3. That's the area of the kite, using exactly the same formula as we had on the previous part. So the area of the sector, what have we got then on that? What is our angle in the middle? If this is 60 degrees, then this is going to have to be 120 in order to get everything to add up to a quadrilateral. So we've got a third of the circle. So it's going to be 1/3 of pi r squared, which is then going to be, well, pi divided by 3. So therefore, area of pi divided by 3 is going to be equal to the area of the kite, which is root 3, minus the area of the sector, which is pi divided by 3, which is exactly what they wanted. Right, okay, that just fell out quite nicely. Yeah, that's a nice question. Once you get going on it, there isn't that much there, really. It's knowing where to start, I suppose. Yeah, once you got a kick off on the first part of the question, and you have to start at C for all the reasons I was saying, at the centre of the circle. It's the only real coordinates that we've got that are anywhere near Q, and then everything just starts falling into place. So that was, yeah, quite a nice question.